Hello, ladies and gentlemen. Now we need to talk about delta max. And what we're talking about is how far something deflects or bends when it's under a force or a load. Okay, here we go. Our formula for this is delta max is equal to a point force. This is not to be confused with the axial force. It's a point force times the length cubed divided by 48 times the elasticity times the moment of inertia of that beam. Okay, so what we're talking about is we would have a beam. What this would look like in the lab, we would have a beam and we're applying a force in the center. And then we need to know the length between these two supports. So the length from here to here, this is L, not the length of the beam, the length between the supports. That's the important length. So, because that's what's coming into play with this calculation. And what we're looking for is how far down is this going to go in the center. I wanted that to be a really different color, so let's try that again. How far down does it go in the center? So we're starting from here. So we're looking for this displacement here. This is our delta max. Let's look at some of these terms in units. So our point force is going to be measured in pounds. So that's how much we're applying right at the center of that beam. Keep in mind, this only works if you have a beam supported at both ends and you're applying a force right in the center. And for our calculations, we're only considering rectangular prisms. The length is the distance between the supports, not the length of the beam itself. Elasticity is measured in PSI. It is a property of the material. So like wood has a specific PSI or elasticity, steel has a specific elasticity, plastics have a specific elasticity, okay? I is our moment of inertia based on the shape of the cross-section of that rectangular prism, and it's in quartic inches, and our deflection or delta max is going to be measured in inches. We also need to rearrange this with a little bit of algebra. If we multiply both sides by E, we can move this E over here, and if we divide both sides by delta max, this is an E, sorry. Divide both sides by delta max, then delta max goes over here. So we end up with this formula. So I may ask you to solve for the elasticity of a material based on some measurements, all right? A problem might look like this. We are testing a beam. We apply a point force of 500 pounds in the center of the beam. The distance between the supports is 60 inches. The elasticity of this material is 200,000 psi. And then our moment of inertia of this is a 2x6 in joist orientation. So it's 36 quartic inches. And then we are looking for how far is that going to bend? What is our maximum deflection in inches? Our equation is our delta max equation. So force times the length cubed divided by 48 times the elasticity times I. And then we have our substitution. So this is what I'm going to put in the calculator. 500 times 60 cubed divided by 48 times 200,000 times 36. Keep in mind these parentheses are very important to keep your calculation organized. If you are more comfortable doing this in multiple phases, I encourage you to do so. This is how I would calculate it all in one go. And when you do that, you're going to see that the solution is a delta max of 0.3125 inches. It's going to be common that your answers here should be very small. I think some of them might be an inch or two, but most of the time it's going to be a decimal. So keep that in mind to check the sanity of your solutions. And that's all I have to say about delta max.